positive. Always positive. I knew that's what you were going to say. And see why it's so easy for me to teach to an empty classroom, because I just answer myself anyway. Absolute value is always positive, which means when you graph it, what happens is you always get this V-shaped graph. So if we graph the absolute value of x, think about if I pick some points here, like -2, -1, 0, 1, and 2. Definition of absolute value, numbers distance from 0. So when I plug in a negative number, I get out a positive number. When I plug in a positive number, I get out a positive number. Yes? So when I plug in -2, I get 2. When I plug in -1, 1, 0, 1, 2. So make your graph. -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. So maybe it kind of looks like a parabola-ish to you, but it's not a parabola. It's a V-shaped curve with a sharp corner. So you can just connect it like this, right? This side would keep going out. At 3, I get 3. At 4, I get 4. At 7, I get 7. So every absolute value function that you make will be in the shape of a V. So when you see absolute value on a test or quiz, you at least make a V-shaped graph. Even if you're going to make another V-shape, you draw a V-shaped graph. So at least I know it's a V-shaped graph. Any big numbers? Pretty sure that's not at least for me. Right, exactly. So the other thing that we want to do is we want to give the domain range of all these functions. So remember that when we're talking about an equation, the domain and the range are not just going to be a list of numbers. Probably there's going to be at least an infinity or a negative infinity in everything there. So the domain is what can x be. So is there anything x can't be in this problem? Can I plug in any number I want in there for x? I can plug in negatives, I can plug in positives, I can plug in fractions, I can plug in decimals. Which means if x can be anything, what do I write for my domain? All real numbers, right? So I think the best way to write all real numbers is negative infinity to infinity. If you want to write out in set notation, you have to say little x such that x is a real number, which to me is way too much work, right? Make your thing. The domain is a lot of times all real numbers. So if you don't know domain, a really good guess is all real numbers. Okay. What about the range? Am I going to get every y value on this graph? What kind of numbers am I not ever going to get? Negative, right? This graph does not come down here where it's negative. So what is the lowest y value on this graph? 0, and then it goes to infinity. It goes up forever. So in interval notation, we're going to say 0 to infinity, including 0 or not including 0? Including 0. So again, I like interval notation. I'm okay if you use set notation. But in set notation, you have to do the squiggles. You have to say y and draw your lines. You say all y such that, and then you write it as an inequality. So everything starting at 0 and getting bigger would be greater than or equal to 0. I don't care which one you use, but you have to do one or the other. Questions about that? So if we know the basic absolute value function is a v, then I can just throw other numbers in here and we can graph it. So look at the next. The absolute value of x minus 3. You have to make that graph, pick the points, and you have to make sure it's a V-shaped graph. So here's what I want to caution you against. Sometimes you just pick 3 random points, and those are the only ones you graph. So this is what happens a lot. Remember when we graphed linear functions last week, I told you what my favorite 3 numbers to pick were? -1, 0, and 1. Now, those are my favorite numbers when I'm graphing lines, because any 3 points will make a line. Absolute value functions can be a little misleading. So think about what happens if I pick these points. When I plug -1 in there, I would get -1 minus 3, which is -4, but the absolute value is 4. Yes? If I plug 0 in there, 0 minus 3, absolute value is 3. 1 minus 3, -2, absolute value is 2. I don't know why I didn't give you a good graph on this one. I apologize. But I just give you lines here. You gotta make your own. It's good for you. We're back in the olden days when you actually had to write all your notes as opposed to the students. So if I graph this, at -1 it goes up to 4. At 0 it goes up to 3. And at 1 it goes up to 2. Here's what happens on a text. People do that and they're like, there you go. You're gonna miss a lot of points if you did this because you didn't make a V-shaped graph. Right? So when you're picking points, you either have to pick enough points until you get the V shape, or I can give you a hint on what kind of points you should pick. You should start with what makes that go to 0. Like, what number could you pick for x that would give you a 0 for y? 3. So if I pick 3 here, I'm going to get 0. So you always want to start with what makes the absolute value go to 0. And then if you just pick one above and one below that number, you're always going to get that V-shaped graph, and you don't have to just keep picking random numbers. You can. You could just keep picking numbers until we get the V-shaped graph. But if I picked 2, because that's one less than 3, and I pick 4, that's one more than 3, when I plug those in there, 4 minus 3 is 1, 2 minus 3 is -1, of the absolute value, that's 1. I get either side of that V shape. So at 2 it goes up to 1, at 3 it goes to 0, at 4 it goes back to 1. You see, like, as soon as you get the Thank you. So here's also what I don't want you to do. Right? It goes on forever in both directions. So at least you don't have to make this all the way go out just like that. But at least put an arrow on that to show me that you know it keeps going in both directions. Okay? Every absolute value should be a V shape. Domain and range. On the last one, the domain was all real numbers. Is this one also going to have a domain of all real numbers? Is every absolute value graph going to have a domain of all real numbers? Always. Okay? Is the range of an absolute value ever going to be all real numbers? Never, because there's always going to be like that V part that it stops at some point. So on the last one, it started here at 0 and went like this. Kind of slid it over 3 units. Are the Y values still the same? Am I still starting at 0 and going up? Can anybody think of a way that my range would start at a different number? Like, what would that graph look like if my range started at a different value than 3? I moved it up like this. So if my V started way up here, like let's say it started at 4, then my range would be 4 to infinity. Or maybe it would move down here, right? Wherever that lowest Y value is on your graph, that's where your range is going to start. So as long as it's on the x-axis, it'll start at 0, but it could move up and down. Okay? So he's saying it can't go down from 0. Like, could we have this and it be an upside down V? Ooh, you're kind of getting ahead of me. That's what we're going to talk about tomorrow. But it could be of what if it looks like this? How would I be able to get negative numbers in absolute value equation? What if I just put a negative on the outside? Does that then make all my numbers negative? Yeah. So the absolute value itself can't be negative, but if I just put something on the outside of it, then it might flip it over and be negative. And we'll talk about that. Okay? Okay, ready for brand new stuff? Brand new stuff. I'm very excited. The other type of function that we want to talk about today are step functions. And that people are really good at coming up with names and stuff. Because step functions are like steps. If you look behind you at all these other posters behind you that are calculus people names, those are examples of step functions because they look like their steps in that. Okay? So there are two types of step functions that we're going to talk about. One of them is called the greatest integer function. Unless you've been in algebra 2 before, you probably have never seen the greatest integer function. It's a new notation. Look at those weird brackets, right? So this is like the typed way of doing it. If I was going to write this myself, the way that I write it is I do like a bracket and then I do a line. So it's not absolute value. It's like absolute value notation, but it's its own notation. When you see this, it means the greatest integer function. So what does that mean? It means that for every number that you plug into this problem, you have to spit out, or the output is the greatest integer less than or equal to x. Or easier to remember, you always just round down to the next integer. So for every number you plug in, if it's not an integer already, you round down to the next integer. So, some examples here. If I plug 7 into that function, I'm just going to get 7 back. Right? So if it's already an integer, not a fraction, not a decimal, whatever I plug in, I get back the same thing. But if I plug in a fraction or a decimal, the definition of those bars means not just do the positive like absolute value. It means round down. So 7.3 would round down to 7. Any number between 7 and 8 would round back down to 7. Negatives are kind of tricky sometimes. Negative 1.5 would round down to negative 2. Right? Because it rounds down, negative 2 is smaller. And then this is the part that people struggle with. 2.9 actually would give you an output of 2 because you round down no matter what, you round down. So because we're rounding down, that's how we get these little stair steps. And I tried to put a little graph in there that I could use, but then my marker's too fat, like the marker's too fat for me to draw on that. So I made mine bigger, and I'm sorry you don't have a little magic button on your paper to make your graph bigger as well, but you could just draw a graph next to it if you want, if you can't use yours on here. I'm going to make this a little bit easier to do in that I'm going to make this be 1. So like basically I'm going to make it go by halves. I'm going to make this be 2, this be 3, this be 4, this be 5. So instead of 10, I just have 5 on there. I'm not going to do all those. Really squished in. And this kind of seems really scary at first because you've never made a graph like this, but it's definitely a pattern. You just plug in some numbers to see where does each one start. You just follow the pattern. So to kind of think about it, I always start with actual integers. Like if I plug in 0, I'm going to get 0. If I plug in 1, I'm going to get 1. If I plug in 2, I'm going to get 2. So at 0, I'm going to make a circle. At 0, I get 0. At 1, I get 1. At 2, I get 2. At 3, I get 3. With me so far? Here's where knowing the notation is really important. Just like when you see absolute value bars, you know your graph should be a V. When you see these bars, you know that it should be steps. So don't just connect that and make it a straight line. You have to think about how far does the step go. And it's always just until it goes up to the next number. Or think about every number between 0 and 1 is going to round back down to 0. So to show that, I put a little line here between 0 and 1. But at 1, it jumps up. So to show that 1 is not included, I put an open circle there. And that doesn't look like an open circle. I put an open circle to show that at 1, it jumps up. And then every number between 1 and 2 will round back to 1. So I get these perfect little steps that are the same length, and they follow this pattern. And so in third hour today, they're like, can I just follow the pattern? Do I have to think about it every time? No, you don't have to think about it. That's what's great, right? We never want to think. You can just follow the pattern. And so each one of these is just going to be 1 unit long. And what's really nice is that all the closed circles should always be in a line. All the open circles should always be in a line. So you can kind of check. There's no place to make that one. There's no way to put arrows on this to show that it keeps going in both directions, but it does. So what I want you to do is I want you to fill the graph up. So I want you to continue the pattern until your graph's full. Which is why it's good that you made it not so big, right? So see these filled-in circles. I'm just going to go and keep making filled-in circles in the pattern. Here, and we'll have an open circle. Here, and 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 have an open circle. What about the domain and range of this? The domain. Can I plug whatever I want into X? I can plug in fractions, I can plug in decimals, I can plug in negative numbers, I can plug in positive numbers. Every X is going to be used, so that's going to be negative infinity to infinity. What about the range? Is the range going to be negative infinity to infinity? I definitely don't get all the Y values back. What are the only kind of numbers that I'm going to be getting on my Y values? Like I jump from 0 to 1, from 1 to 2, from 2 to 3, right? Am I ever going to get back like 1.7 in the Y column? 2.6, right? I'm not going to get decimals or fractions. So what is that called? Where it's negative numbers and 0 and positive numbers, but no fractions and no decimals. Integers. It's called integers. Whole numbers are just 0 to infinity. We need the negative ones too. So our range is every integer. So it's really hard to write that in interval notation. So I think this is where you have to use set notation. And I'm just going to say, like, you can say all integers here, or I'm going to say where Y is in. And I don't really know a better way of writing it. Because you can't list out all that. You could use like a little E with a line. Do that. So the range on step functions will always be weird because they are stair steps. They are jumping over Y1. So now that you know the basic idea, now I can throw other numbers. So when you see this symbol, you got to know that step function. You got to know that means rounding down. All you really got to do is figure out where are the steps going to start, how long are the steps going to be. So I always do that by just picking some points that are already integers, where I don't have to think about rounding. So like if I pick 0, 1, and 2, if I plug 0 in there, I'm going to get 0 plus 3, which is 3. If I plug 1 in there, 1 plus 3 is 4. And if I plug 2 in there, 2 plus 3 is 5. Those are going to be your closed circles. When you plug in an integer, you get out an integer. If it helps you, you could pick out some in-between numbers and make sure that you know that it's going to work out that way. Like if you picked a half here, order of operations, you do grouping symbols first. These are grouping symbols. So if I plugged a half in there, a half would round back to 0, or rounding down. So a half would round back to 0, and 0 plus 3 means I'm going to get 3 again. So every number between 0 and 1 is going to round back to 3. Every number between 1 and 2 is going to round back to 4. Alright, so I don't usually pick a lot of points. So if I pick 0, oh wait, I want to do my, I don't want to make 10 of these, right? 5 is definitely plenty on each axis. So when I plug in 0, I get 3. When I plug in 1, I get 4. When I plug in 2, I get 5. Again, if you're not sure what to do here, and you just connect that line, that's really that means for your grade, because I want you to know that there's steps. So I picked those 3 points to help me get started. Like I said, kind of seeing the pattern, because the step will end when the next circle is filled in. So I know to stop my step when I get to that next closed circle above it. So that's how I know that at 1, I jump up there. And then this one ends right there. Same length. Questions on what I'm doing. The other thing I don't want you to do is just graph that and move on to the next problem, because where's the rest of the graph? Right? I can't just put arrows on it, so we can't go any more this way, but I do want you to fill it back in this way, which is why I said this to make your graph not so much. So I think it's easy to just kind of like line it up and see where each of these would make a straight line, right? And everyone is just going to match and be the open circle under. And we said last hour, and I like that it lines up, because I can check that I did it right, or at least hope that I did it right, because all the solid ones are in a line, all the open circles. Domain, all real numbers. Range. Skipping everything in between integers, right? So it's just all the integers again. We'll probably look at some tomorrow that maybe have a different range. How can we make it? Usually when I teach this, I have a topic for the first time in a long time. I haven't taught out for 2 and a few years. But usually people, when I teach something different or difficult, the automatic reaction is like, this is stupid, I'm never going to use this, right? That's actually those reactions. That's something difficult. And you might think this doesn't ever apply anywhere. But rounding down, maybe not. But rounding up, right? Think if it was the function where you round everything up. Lots of people charge you, like lawyers charge by the hour. I think we even cut it down to by the half hour. But if you only see a lawyer for 20 minutes, guess what? They're going to charge you for a half hour. They're going to round up that charge. That is a step function. So the one other thing, and I'm not going to go through this example, I just want to explain it to you really quick. The one other type of step function is a ceiling function. And the definition of a ceiling function is just that you round up instead of you round down. So this one really does apply in so many places in real life problems, because so many places will round up and charge you more instead of charging you less. So while I get ready to think about the homework, or pass out the homework, look at this graph compared to the last one and tell me, how does it look different than the one we just did? It looks really close to the one we just did, right? The dots are opposite, because now we're rounding up instead of rounding down. So everything between 0 and 1 rounds up to 1 instead of down to 0. And so depending on if it's a ceiling function or a greatest integer function determines whether it's open circle, closed circle, or closed circle, open circle. Also notice that the notation is different, right? We have lots of similar notations. Ceiling functions, I remember it's a ceiling function, so the things are at the top, right? Also, the ceiling is above you, so that's why you got up. domain still be all real numbers? Yes. And what about the range on this? The range would still be all integers? So there's one more example here that I'm not going to do because I want to give you a minute to at least start this. But notice on this worksheet there are 4 questions that you have to graph. Maybe the first thing you should do is go through and mark what type of function it is. Is it an absolute value function? Is it an integer function? Is it a ceiling function? So for a ceiling function, the only difference between it and an integer function is the way that it's looking, right? I also want you to see the domain and range. Use your notes to help you. And then on the back, and I had one to make a numeric equation. Right? Please try this. Hello? I just stopped. Maybe you're supposed to go to office. So please start this. Let me know if you have a question on where to start. Use your notes to help you find these things, let us find it, take your numbers, make sure you at least have the sheet on there. We won't for sure have homework for tomorrow. It will for sure be graphic on homework for tomorrow. Probably end up with topics, okay? And maybe tomorrow you'll get to make a paper to look at it. At least, zip it.